Hi everyone, and welcome to a video about how to create a matrix inverse and how to use that to solve a systems of equations. The first thing that we're going to do is talk about how to create that matrix inverse. In order to do that, you need to know how to find a determinant of a matrix. So if you don't know how to do that, revisit lesson 4 and we'll talk about it there. To find the inverse of a 2 by 2 matrix, what you do first is you find the determinant and its reciprocal. Then you switch the numbers on the main diagonal. So I'm switching this entry A with entry D. And then you change the signs of the other two entries. So notice D is now here, A is now here. This is now negative, and this is now negative. Now, if they were already negative, they would turn positive. The final step is to actually multiply this determinant into every single number in your matrix. And I know that seems like a lot of steps, but let's go through them one by one using an example. We've been asked to find the inverse of matrix A if it is defined. So step one is to find the determinant of this matrix. And we do that by multiplying -2 times -4 and then subtracting 3 times 2. So this is 8 minus 6 to get 2. Now, if that 2 happened to be a 0, then this matrix would not have an inverse because later on when we need to do the reciprocal of 0 is undefined. So we can't do it. So let's do step 2. Step 2 is to move around some numbers and change some signs. We need to switch the numbers on the main diagonal. So this -2 and this -4 get switched. See the red numbers over here. And then we need to change the signs on the other numbers. So any number that I didn't move, the 3 and the 2, is going to have a different sign than it already had. Okay, now it's time for the last step, and that involves the determinant and our kind of changed up matrix. We need to multiply the new matrix by the reciprocal of the determinant. Our determinant was 2, so I'm going to multiply 1/2 into this new matrix. So I did 1/2 times -4 is -2, 1/2 times -2 is -1, 1/2 times -3 is -3/2, and 1/2 times -2 is -1. So this is our inverse matrix. Now, if you want to check your answer, what you would need to do is do the original matrix times our inverse and make sure you get the identity matrix, which would have a diagonal of 1s, and these other two entries would be 0. And then you'd have to do it in the opposite order, the inverse matrix times matrix A, and make sure you also get that identity matrix. That's how you would check it. Okay, but I promise that this one is correct. So let's take a look at another example just to make sure we understand what's going on. We've again been asked to find the inverse of this matrix if it's defined, and we're going to start off by doing the determinant. So I need to do 12 times 1/2 minus 3 times 2. When I do that, I get 0. This determinant is 0, so we can't do the reciprocal of this because that would be undefined, and this matrix would not have an inverse. So let's see a way that we can apply inverse matrices to solving systems of equations. So what we can do with a system of equations is change it into what we call a matrix equation. And what we would do is take all of the coefficients from our variables and put them into a matrix. We call that the coefficient matrix. Then we take our two variables and we put them here in our variable matrix. And it's going to equal what we call the constant matrix, the constants that are here. Now, when you're creating a matrix equation, you want to keep in mind that the x's should be lined up, the y's, then the equal signs, then the constant numbers. So it's very alphabetical if you think about it that way. And notice that if I was to multiply this coefficient matrix by my variable matrix, it would actually equal this in a matrix. You would have x, y, 2x, and y in a matrix. So it makes a lot of sense if you think about it in terms of matrix multiplication. Now, in order to solve this matrix equation, Like you have a number times x equals a number, you would divide by this number. But remember, we can't really divide matrices. So what we're going to do is multiply by the inverse of our coefficient matrix. So I would find the inverse of this and do that inverse times our constant matrix. And that's going to get me the answers to x and y. Let me show you an example and it'll be more clear. In example 3, we've been asked to write the matrix equation for the system and solve. So step 1 is, of course, to write that matrix equation. Now, this may look very similar to what you saw on the previous slide because it is. So we're going to go ahead and take our coefficients, make a coefficient matrix, take our variables x and y. It's going to be x on top, y on the bottom. It's going to equal 8 and 1. So here is our matrix equation. Now step 2 is to find the inverse of this matrix. And in order to do that, we do the determinant. So that's 1 minus 2, which is negative 1. We switch these ones and change the signs on this. Then we multiply by the reciprocal of negative 1, which is negative 1. So let me show you that work and the inverse matrix. Here's the work for finding the inverse. I switched these numbers, I changed these signs, and I multiplied by the reciprocal of negative 1. And I got this blue matrix. Now, in order to find the final answer, I have to multiply the blue matrix with my constant matrix. And the order of that multiplication needs to be in the order that would work. This is a 2 by 2 times a 2 by 1. So this one comes first, and then this one. And then you just do the matrix multiplication. So I did negative 1 times 8 plus 1 times 1 to get negative 7. And then I did 2 times 8 plus negative 1 times 1 to get 15. Now this is what I like to call the answer matrix. And notice the x was on top and the y is on the bottom. So x is going to be negative 7 and y is going to be 15. And that's going to be my answer to this system of equations. So that's it for this video. I'm going to have a separate video showing you how to find a matrix inverse using a calculator. So stay tuned.